Okay, so now we're going to start section 1.3, linear functions, and we're going to look at mathematical models. And the first type of model that we're going to be using, lines, is for revenue, cost, and profit. So I'm going to take a look at number 14. A manufacturer has a monthly fixed cost of $100,000. Now, what does that mean? It means just to open the doors, you have to come up with $100,000 per month. You have a lease, a rent, whatever. You have insurance. You have electric bills, etc., etc., etc. All kinds of insurance that you have to have. So right off the bat, you need $100,000 a month, and whatever you produce costs you $14 per unit, and you could sell that item for $20. Now notice this business is feasible, and the reason I say that is you sell it for 20 and it costs you 14, but remember you have to produce enough and sell enough so that you can not only cover the per unit cost, but also your fixed costs. So what we're going to do here is we're going to come up with what is the cost function, what's the revenue function, and what's the profit function, and what's called the break-even point. And I'll show you geometrically what that means. Now, so you're going to have to come up with 4 things. So each of these will be worth 1.25 points. Because if you add them up, that gets you 5 points. Okay? So here's the situation. We have to look at each of these individually. So let's take a look at the revenue cost. The revenue, not the cost, excuse me, the revenue. So if you sell one object, you make $20. Or you bring in, I should say. If I sell 5 of these, I get 5 times 20, which is $100 revenue. So in other words, the revenue function is just a straight line that passes through the origin, and its slope is 20. Now, cost. You have 2 types of costs here. You have the per unit cost, that was the $14, and you have your fixed cost, which is bad, which is $100,000. So your cost is the individual per unit cost plus your fixed cost. So if you get to this point, you get 1.25 points. If you get to this point, you get 1.25 points. And so your cost is, if you take a look at this, if x is equal to 0, in other words, you're not producing anything, you still have to cough up $100,000. So what this is saying is the 14, which is the slope, is the per unit cost. And the, quote, y-intercept is your fixed cost. So you have your per unit cost and your fixed cost. Okay, so if you get to this point right here, you get another 1.25 points. Now, how do you calculate profit? Well, it's how much you take in minus how much you have to pay. So what you're doing is you're taking the revenue function, subtracting off the cost function. Now, this is a common mistake students make. You have to negate the entire cost function. This is a very common mistake where you just subtract off this, but you don't change this. All right, so if I negate everything, now I'm going to take the 20 minus the 14, which is going to be the 6. So 6x minus 100. In other words, you're making $6 per profit per unit. Notice if you did not negate this, and if you left this as a plus, you have a plus here. You'd have a plus here, which does not help your profit. It's decreasing your profit. So if you get to this point, you get another 1.25 points. Now let's take a look at the two functions. So the revenue function is a line that passes through the origin, and this slope is steeper than this slope. So here's my revenue function, and here's my cost function. Okay? So here's my R. Now, if, excuse me, so let's ask the question, suppose I produce this much of whatever I'm producing. Is this a good situation? Well, I don't think so, because the cost is bigger than your revenue. You're losing money. Suppose I go on this side. Is this a good situation? Now your revenue is bigger than your cost. The difference is your profit. This is where you want to be, on this side. This guy right here is called your break-even point. In other words, your revenue is the same as your cost. So you're not making money, but you're not losing money. So it's good to be on this side. It's bad to be on this side. This is called your break-even point. Now, how do you calculate that? It's where your revenue equals your cost. Or you could think of it's your profit is zero. So if I take my revenue equals my cost, so here's my revenue function, here's my cost function. We want to solve for x, so you're going to subtract the 14x, so you're going to 6x equals $100,000. Now you divide by the inverse operation of multiplication by 6 is division. So I divide by 6, but now I get 16,666 and 6 repeated. So to make sure that you're not losing money, you have to round this up. Okay? So because you don't make 2/3 of a product. You either make one of them or two of them, but so what we're saying is you don't make 2/3, so I'm going to round it up to 1. 6.6 and 2/3 gets rounded up to 7. Okay, another type of problem that you're going to be working with is something called linear depreciation. And so we have this textile company purchases a machine for $250,000. Okay, the scrap value is $10,000, quite a bit less, with a useful life of 10 years. So here's the situation, folks. If you have a machine that is working very, very, very hard, there comes a point in time where it is so expensive to keep the machine running because you have to replace so many parts with it, and then you have downtime, etc., and you're not doing production because the machine is being repaired. So what this is saying is, at the end of 10 years, it's actually beneficial to just junk the things, sell it for scrap, and the scrap value is only worth $10,000. And so what we want to find is the book value function, which is going to be a linear function. And then we want to answer a question like, well, what's its value worth 6 years, when it's 6 years old? So I want you to notice something. We have two types of things going on here. We have money and we have time. This is key, keeping things straight. Now, you'll remember from algebra that when we had this column, this was what we called the x's, and this was what we called the y's. So I could put the book value here and the age, or I could put the age and the book value. Now I want to remind you something. Whatever I choose for my x is my independent variable, and whatever I choose for my quote y is my dependent variable. This depends on this. This is very important. This number depends on this number. Let's go back and see if this is the way we want to present the information. The age of the machine depends on its value. Okay. let's try reversing this. The value of the machine depends on its age. This is the one that makes more sense, not this one. Technically, there's nothing wrong with this. Now, the reason I bring this up is because in economics, they are actually going to reverse this. They're not going to do it this way. And so when you talk with the business world, they're going to want to do it this way. When you talk to economists, they're going to want to do it this way. So just trying to give you a heads up on what happens in the real world. Business world wants to do it this way. Economics wants to do it this way. So when the object is brand new, it's worth $250,000. 10 years later is its expected life, and it's only worth $10,000. So we could plot, and we have 0, 250,000, and then we have when it's 10 years old, it's worth $10,000, and obviously the slope is what? A negative number. Okay. So what this is telling us is that I put my information in, so I take 10,000 minus 250,000. Its useful life is 10 years, and it started at 0. So I take 10,000 minus 250, I get minus 240,000. Divided by 10, so that just knocks off 1. So, in other words, your slope is a minus 24,000. Now, what is the physical meaning of that? What that means is that machine is depreciating at $24,000 every year. Okay, so now how do I find the equation, the book value? So I have the book value, and I'm going to pick the one with the 0 for the time. So I take the book value minus the 250,000, so that's my y. My slope is minus 2,400. T minus 0. Notice I picked the one that had a 0 in it. So now we could just, so T minus 0 is T. So we have minus 24,000 T minus 250. So now I can add the 250 to both sides. And I got, this is a 0, not a 9. And here is my formula. So if you get to this point on a quiz or test, you get 4 points. Now, because you have to tell me what was it worth at, I think it was 6 years. So we could check this formula. If I put in a 0 here, that means you just bought the thing. This is wiped out, and your value is $250,000. Makes sense. Let's see, 10 years is its useful life. So if I put in a 10 here, then I'm going to get minus 240,000 times 10, which is minus 240,000 plus 250, which is 10,000. So yes, you have the correct formula. Okay, so now if I want to know what's it worth when it's 6 years old, so what do? I put in a 6 for my time. And I just do the arithmetic. So I get minus 144,000 plus 250,000. And if you just do the arithmetic, you get 106,000. So that means that when it's 6 years old, you basically, dropped it by about a third. Okay. And the last thing I want to talk about here is the market equilibrium, supply and demand. And this is really in preparation for when you take economics courses, because this is going to be a big one. Now, what the economists are going to do is they're going to put the demand, I'm going to call that Q for quantity, on the x-axis, and they're going to put the P for the price on the vertical axis. And we want to think about the following. We have two viewpoints. We have a consumer's point of view, and we have a supplier's point of view. Okay, so if I have, let's say that I'm collecting DVDs, okay, and I only have a fixed amount I can spend every month. So, and this is from the consumer's point of view. Now, if the price of the DVDs goes up, and I'm thinking of this from the consumer's point of view, then you're probably going to buy less. Now, this is not, we're not talking about things like the stock market where you're betting, basically, on, you're gambling on what the market is going to do. So if the price goes up, you're probably going to purchase less. On the other hand, if the price goes down, then you could purchase more DVDs. The supplier, on the other hand, so what we've got here is if the price goes up, you buy less. If the price goes down, you can buy more. That doesn't mean you will, but I'm just saying there is a potential. The supplier's point of view, however, if the price goes up, they're willing to drill more oil or do fracking. If the price goes down, then they lose incentive. So we sort of have this competition between the two players, and this actually comes about in the mathematics called game theory. And you could think of it, for example, as a batter and a pitcher in a baseball game. The pitcher is trying to do what? Keep the batter's average as low as possible, while the batter is trying to get their average as high as possible. So you have this competing scenario here. Where one wants something to go low, the other wants to go high. Okay, so let's take an example here. So suppose I tell you that the demand for an espresso maker is 250 when the price is 140, and when the price is 110, the demand is 1,000. Now we have to figure out, is this the consumer's point of view or is this the supplier's? Well, I gave it away. The supplier is willing to produce 750 of these espresso makers when the price is $60. When the price is $80, they're willing to produce this. And that, I think that makes sense, right? So from the supplier's point of view, if it's $60 the market, then I'm willing to produce $750. When the price goes up, I could produce more. And so the question comes up is, what is the consumer's function and what's the supplier's function? Okay, so what that means is we're just going to be looking for a straight line. But I suspect what's going to happen is the consumer or the supplier, one of them has to have a negative slope and one has to have a positive slope. And we've got to figure out which was which. So let's take a look at the consumer. Now remember, the economists take this as the convention. The quantity of demand and the price is the y-axis. So what I'm going to do is I'm just going to plot the points. So this is from the consumer's point of view. So the demand is 250 when the price is 140. The demand is 1,000 when the price is 110. Notice when the price goes down, the consumer is willing to make what? Almost a factor of 4 times. Does this make sense? If the price goes up, so we're going from here to here, the demand goes, did I say that right? Yeah, so demand goes down. Okay, quantity goes down. And we have a negative slope. Now, be careful. The Q is going to be your X, and the P is going to be your Y. And we should have a negative slope there, right? So, if I take the slope, so if I take the difference in the Y values divided by the difference in the X values, 40 minus 10 is 30, and 250 from that is negative 750. And so I divide by 10, and then I have a negative slope. And is 75 divisible by 3? Well, you remember that trick from high school that if you, excuse me, if you add the digits and that's divisible by 3, the original problem is divisible by 3. So if I take 7 plus 5, which is 12, 12 is divisible by 3. So 75 has to be divisible by 3. And in fact, we all realize 75 is 3 times 25. So, so the 3's, sorry, I've got to bring this up. So the 3 is going to cancel with the 3, and I'm left with just minus 1 over 25. Okay. So now I could put the, I've figured out what my slope is. So this is going to be my quote x, this is going to be my y. And I just distribute. So I'm going to distribute the minus 1 over 25. This is going to be plus. So 250 divided by 25 is 10. Now I'm going to add a 140 to both sides, so this becomes 150. So now I put a little subscript C here to remind me that this should be the consumer's point of view. Okay, now can you check to see if this is correct? Yeah, just substitute in when the demand is 250. So I put in a 250 here, and I do the arithmetic. I get 140 is the price. And then you could check your other point as well. I'm not going to bore you with this. You could just substitute in your 1,000, and if this is 1,000, then you have minus 40, and this matches up. So we're good to go. This is our actual linear model. Now we go to the supplier's point of view. And the supplier says, okay, when the price is 60, I'm willing to produce 750 espresso makers. When the price goes up, I'm willing to make more. So by a factor of about roughly 3. So let's plot 750, 60. Excuse me, so 750, 360, or 60, excuse me. And then 250 and 80 is this. So the producers, the supplier, has a positive slope. And that makes sense because if the price goes up, or I should say, either way you could look at this. If the price goes up, I'm willing to produce more. Price goes down, I'm willing to produce less. So when we try to figure out what the slope is, this has to be a positive number. Okay, so if I take the difference in the y, so 80 minus 60, whoops, 80 minus 60 divided by 2250 minus 750. So upstairs we're going to get 20, and then we get 1500. Now this can obviously simplify. So we could pull out at least a factor of 10, and then we could pull out a factor of 2, 1 over 75. So now I just put in my information into my point slope form, and I just do the arithmetic. So we're going to distribute the 1 over 75, and 750 divided by 75 is going to be 10. Then we add 60 to both sides, and we get 50. So this is the supplier's point of view. And again, you could check to see if that is correct. And you do that by putting in your Q. So this is going to be what? 10 plus 50 is 60. That works. If I put in 2250 and you do the arithmetic, 30 plus 50, we get 80. And we have the correct formula.